Hello and welcome back everyone, and we'll continue on with the other rules. So the next rule that we are going to look at is rule 2. So rule 2 states that the absolute value, which is x minus y, is equals to y minus x. Now I think you can notice that we are now using two variables instead of one. Previously in rule 2 we have seen how we can work with one single variable and what we can determine after that variable has been evaluated according to the steps. Now in this rule we are not going to only use we are not only going to use two variables, but we are also going to see at the end of this rule too that how we can take the previous rule and how we can apply rule 1 inside rule 2, and at the same time we will see that both of this rule will act congruently, or they will act in conjunction with each other, so that we can prove how rule 2 is working. So let's get started. So first of all, let me consider, or let me actually segregate or dissect. I don't know that whether that's the actual term, but let me segregate this equation, which is the absolute value of x minus y, which is the left hand side, and the right hand side will be the absolute value of y minus x. Now I'm going to use the left hand side for both of the purposes, and in this context we are only going to use, or we are going to focus primarily on two steps, because one of these steps is quite irrelevant. The reason is, in previous rule we have seen three steps. Likewise, you might be thinking that we might also go for three steps, but that's not the case, because step 1, which actually assumes that all the values are 0, then this will render out to be 0. That's not what we want. We want to prove that we can segregate this equation into left hand side and right hand side, or two components that can be regarded as left hand side and the right hand side, and then we will take one of these components, and then we will transform it, or we will prove that we can reach by using this rule on the other side or on the other hand. Let's do that. The first thing that I wanted to show you was when x and sorry for that, that shouldn't be a comma, we should be assigning a value. So when x equals to 0 and when y equals to 0, so we actually consider both of those values having set to a constant value of 0. Now if we consider the left hand side, now this step is actually quite irrelevant, and that's what I'm going to show you. If you consider x minus y, it's not exactly irrelevant, but in this context, in the context of proving that left hand side equals to right hand side, we don't actually need the first step, because if we consider this, then if we put this 0 minus 0, okay, that shouldn't have been a y, that should have been 0 minus 0, then we can see that we get something like this. So this is not the case that we want. So let me put an asterisk in here. This asterisk actually means that we don't need this step. I think I lost my cursor. That's weird. Okay. We don't need this step. So in this context, in the context of rule 2, we don't need this, because our intention was to prove that left hand side is equals to right hand side, and that will always be the case when we use rule 2. But in this context we see that we do get a value that's which is unintended, and we don't want that. So what we want is to show or to transform this left hand side into an equation or the segregated component, which is y minus x, or the absolute value of y minus x. That's the way we should say it. Now let's go to step 2. Now from step 2 onwards, or step 2 and 3, these two steps are actually crucial ones, because using step 2 we will actually see how to transform left hand side to right hand side, and using step 3 we will see how to apply rule 1 in rule 2 to show that rule 1 actually contextually can also belong in the proof of rule 2. So let's get started. So now we are going to consider that when x is positive, so this means that x is greater than 0. Let's also consider that y is positive. Now in this context too, y should be greater than 0. So likewise, I'm also taking the concepts from rule 1, and in rule 1 we have seen how we can actually draw a number line and represent all these variables on the number lines. So let's do that. So it will get a lot easier for us, but the concepts actually apply for both of these variables, so we don't need to worry about that. We just have to assign two variables and show them graphically on the number line. So let me scroll down and let me draw a number line.